Okay, let's give you guys some more practice. So here, given this here, work out dy by dx here. So given that y equals this thing here, work out dy by dx. So the one that you will need will be this one here, the inverse cos one. Okay. So yeah. So given this, work out dy by dx. Oh, but by the way, now I've stuck a 2 in here, so you can imagine as this. Even if there's a 2 here, remember when you differentiate it, if you differentiate both sides, let's say you're going to differentiate both sides. So operate this to both sides here. D by dx, operate it on this whole thing here. So inverse cos, and then blah 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 here, and then because the number 2 here is a constant, we can actually take it out. We can actually take it out. Remember from from our section on limits, because this here is a constant, we can actually take it out here. So you can just visualize as this. Take the 2 out and concentrate on differentiating this d by dx of the inverse of cos blah blah here. So concentrate on differentiating this thing here, and once you've got your whole answer, then times it by 2. So even though there's a 2 there, you can, well, it's like me asking you to differentiate this. Differentiate this. Hang on. It's like me asking you to differentiate this. You would just pretty much ignore the 2 and just concentrate on differentiating this. So this would be 2, and then you would concentrate on differentiating this here would be this, and then you would merge the 2 together, giving you minus 2. Well, minus 2 sine x here. Well, it's pretty much the same thing here. Even though there's a 2 in front, do whatever you want. Find dy by dx. Okay, so the one that you would need here would be this one here. Okay, so anyway, find out dy by dx. So press pause and have a go. Okay, so to do this here, operate, differentiate both sides. So do the operation to both sides here. So differentiate this side, and then this thing here is this thing here, and then because 2 is a constant, you can actually take it out here. So just concentrate on differentiating this. Okay, and then that would take you to this. So when you concentrate when you try to differentiate this here, you've got to use this formula here. You've got to use this formula here. So whenever you want to differentiate this, it will give you this. So this thing here is this thing here. Okay, so differentiate this, it will then give you this. But then because you've got a bubble here, you've got to differentiate the bubble itself. That will then give you this. Okay, so basically you've got one block multiplying with this block here, multiplying with this block here. They're all multiplying with each other, so we don't really need the brackets here. But just see that you've got one block here multiplying with this block, multiplying with this block. But when you come to do this, when given this here, try to jump to this in one go. Try to jump to this in one go. Okay, so take it straight to this this stage here, rather than having to go through these 2 steps here. Okay, so from here differentiate it. It would take you to here. But then don't bother putting the brackets in. Just visualize it as one block multiplying with another block multiplying with this block here. Okay, so now you've got 3 blocks multiplying with each other. This block here gets multiplied to the top. This one here also gets multiplied to the top. So that will give you this. And then the bottom one, tidy this up. So that will give you this here. So overall dy by dx equals this. And then get yourself a graph plotter. Plot your original function here, the original function here, and then plot your new found solution, which is a blue line here, and then have a quick glance to make sure that everything makes sense. So looking at the red line here, right here, the gradient is 0. So now looking at the blue line, right here, when x is 0, the gradient itself is at a level of 0. Okay. Now looking at this, let's say looking at this point here, looking at the red line here, hang on, at this point, looking at the red line here, the gradient is positive, quite steep. So hang on, all the way up here. Now looking at the blue line, it is at a positive level. It is at a positive level, and it's quite high. Looking at over here, notice that the gradient should be negative, and it's quite shallow. So looking down here, looking at the blue line now, it is at a low level, and it is on the negative side. So everything seems to make sense. So we have a hunch that this here is correct. Okay.